A step 2 question then, 2009, step 2 question number 6 is also question 5 from the miscellaneous pure step 2 support module. It's a Fibonacci question, which I hate. I don't like these questions at all, but we'll just do it anyway. I just need to practice them, I think. And we get a free mark for just being able to add stuff up, so that's all good. S is the sum of the reciprocals up to infinity of Fi, so it's just this. Now we're being asked to show this thing here. Now you can do this by induction, but the easiest way is to just get out the definition of the Fibonacci equivalence and then just argue that, well, f of I is bigger than f of I minus 1 for every I bigger than 2, right? Like it's not true for f of 2, that's not bigger than f of 1, but it is true every single time after that. So therefore, if we just add 1 or take 1 away from the I, sorry, from both, this is true for all I bigger than 3. And if we argued that then we can just go back to here and we can say, okay, well, let's just replace f of I minus 2 with f of I minus 1. Now that's replacing it with something bigger than what it is. So therefore, we're making this side bigger, and we have f of I is less than this, as long as I is bigger than 3, or bigger than or equal to 4. I guess you could also define that as, and therefore f of I less than 2 f of I minus 1, and then we can sort of cross-divide, which we're allowed to do because all the f of i's are positive, so it's not going to mess with the inequality. And we end up with this thing here, which is what they were asking us to get. And then deduce that s is bigger than 3. Now, to do this, you're supposed to use the result we just used, which I will do later, I promise. But for now, I just decided to be as lazy as physically possible. I just decided, well, why don't I just add up enough terms to get bigger than 3, and that'll be fine, And it turns out if you do 5 of them, if I just ignore every term after this, I'm making this side smaller, right? So s is definitely more than the first 5 times added up, because you're supposed to add up infinite terms. So if I just add up the first 5, it turns out you get something bigger than 3 without too much effort. And therefore s is bigger than 3. Now you're supposed to use this result, and I will use that later, but this is the exceptionally lazy way to show that. It doesn't say hence, so I'm allowed to do that, I think. Now show that s is less than this. Now we do actually have to be intelligent, because we're doing a less than the other bound instead. So okay, how do we do this? Well, here's s. And now what we're supposed to deduce here is that this result, although I didn't use it, was supposed to be very helpful for deducing this. So if we're now deducing s less than something, we want to use a similar result, but not quite this. We want to use something that's equivalent to that, but it's going to help us do the less than case rather than the more than case. So okay, how can we get a similar result to this? Well, let's just think about how we made this and just do the same sort of thing. So we got out the definitions of the Fibonacci sequence. We decided these two things were fine. And so instead of replacing the fi minus 2, why don't I just replace the fi minus 1 with something smaller than it, which of course makes this entire side smaller. So therefore f of I is definitely bigger than 2 f of I minus 2. And so then some cross-dividing again, and we end up with this here. Now, this could be helpful if I go back to here, and I'm not sure how you're supposed to see this trick without having just seen this kind of thing in Fibonacci questions before. But what I'm going to do is I'm going to try and force this result in here. And the way to do that is to split. I'm going to ignore the f of 1 and f of 2 terms, but I'm going to split all the rest of the terms into evens and odds. And the reason I'm going to do that is because now my plan is to replace this f of 6 here, replace this 1 over f of 6 with 1 over 2 f of 4. And I'll be replacing it with something bigger than it, which means this entire side will become bigger, which means this side will become a less than sign because s will be smaller, which is exactly what I want to happen. So I'm going to replace all of these terms, the 6, the 8, the 5, and the 7, and all the ones, of course, afterwards, with the ones 2 less than them, and double every term while I'm doing it. Now, where does that get me? I mean, it gets me the less than term, which is fantastic. But where else does it get me? Well, why don't I just do it again, right? I can replace 1 over f of 6 with 1 over 2 f of 4, but it's already a 1 over 2 f of 6. So that will be replaced with a 1 over 4 f of 4. And likewise, this one, a 1 over 4 f of 3. And if you just keep doing that, you're going to get the sequence 1, 2, 4, 8, 16, and so on, because you'll just have to do it one more time, one more time, one more time, and every single time you do it, it doubles. I hope that makes sense. And now, of course, we can factorize out 1 over f of 4 and factorize out 1 over f of 3. And now this sum we're going to see a couple of times in this video. So let's just very quickly work it out. A is what? It's a geometric sequence, obviously. A is 1, r is a half. Sum to infinity is a over 1 minus r, which is 1 over 1 minus a half, which is 1 over a half, which is 2. So this is 2, this is 2. We can now just put in these first 4 f's that we have all the answers to. The first 2 are 1s, of course. So it's 1 over 1 plus 1 over 1 plus 2 over 3 plus, yeah, plus 2 over 2, I guess, is what that's going to be. The 2's here come from the fact that that's a half, that is equal to 2, as we said. And now if we add these together, we'll get exactly 3 2/3. But remember, s was less than that, so therefore we've shown what it is we were meant to show. Again, can't stress the importance of, if you've just done these Fibonacci questions before, this kind of trick, I think, turns up a few times, so it's maybe seeable through that. Show further that s is less than, or sorry, it's more than 3.2 and less than 3.5. Classic step things now. We've already shown that it's between 3 and 3.666, I guess. Now just show it's more strict. So all we have to do is repeat the process that we've been talked through, but just do it more accurately. Do it maybe to more terms in this case. So classic step things. So okay, this time, again, to get to the 3.2, the bigger than 3.2, you could just add up terms until you get to more than 3.2. There's absolutely no need to make this any more complicated than that. Just add them up until you pass the threshold. But if you want to do it the proper way, and what you can do, and I've substituted in them all up to 1 over f of 5. F of 5 is just 5. So I've gone to f of 5, and now here, what I'm going to do is I'm going to replace 1 over f of 7 from this one, the one we haven't actually used yet because I did the first one the lazy way. I'm going to say 1 over 7 is bigger than 1 over 2 f of 6. So if I replace this with a 1 over 2 f of 6, I'm going to make this entire side smaller because I'm replacing it with something smaller than it, which makes this a more than sign, right? Because s is now going to be bigger than this thing. And likewise, 1 over f of 8 can be replaced with 1 over 2 f of 7. But now I can repeat the trick I did in the last one, right? This is now 1 over 2 f to the, 4 f to the 6. And that's even smaller, so this sign is still okay. It's still going to be even smaller than it was before. And now factorize out 1 over f of 6, which is a 1 over 8. And you get this 1 plus a half plus a quarter business, which we know is 2. So we can replace that with a 2. 2/8 is a quarter. And now if we just add up all these things, I added up the first 2, the second 2, and the third 2 alone like this makes 154, I think, if we do some cross multiplying over 120, which is 3 and 34 over 120. And 34 over 120 is slightly bigger than 0.2, I think. Oh, I halved them both, and then I just said, yeah, this is 0.2, isn't it? Because that times 5 is that. So this is bigger than 3.2. So it actually seems like I maybe went a bit too far. I'm not really sure, but it's definitely bigger than 3.2. So s is therefore bigger than something that's bigger than 3.2. S is definitely bigger than 3.2. Maybe I went a term too far. I don't know, but I've definitely shown the thing, I think. And now on the other side, of course, we're going to be using this result instead, just like we did the first time. So we're going to do exactly the same thing. We're going to split it into evens and odds. And the way to get it more accurate is just to keep a couple more terms at the front here, which are unaffected. We start the evens at 6 and we start the odds at 5. That's the way to do it. And again, we'll replace 1 over f of 8 with 1 over 2 f of 6, thus replacing it with something bigger, which makes this entire side bigger. So s is now smaller. If I do that, I'm going to do that for all of them, replace them with 1 over 2, 2 less than they were. And then, of course, replace this with a 1 over 2 f of 6, which makes this whole thing 1 over 4 f of 6. And likewise here, factorize out the 1 over f of 6, factorize out the 1 over f of 5. This is a 2, this is a 2. Put all the numbers in, as I've been doing. 1 over f of 6 is an eighth, times 2 is a quarter. 1 over f of 5 is a fifth, times 2 is 2/5. To start adding these things up, I added the first 2, the second 2, and the third 2 alone like this. That makes 165? No, 178, yes. Yeah, sorry, I did 5 times 30, didn't I? 178 over 120, which is 3, and 58 over 120, I think. And now 58 over 120 is slightly less than a half. So this is slightly less than 3.5. So I've shown s is less than something that's less than 3.5. So therefore s is definitely less than 3.5. And that's all that done. And that's the whole question done. Thanks for watching.